Hypothesis testing is another component of inferential statistics. Meaning this is another process for taking sample information that we collect and using that to make an inference about the larger group, the population as a whole. The first thing we want to start off with is talking about the null and alternative hypotheses. These two statements exist for every test. First, we have H with a subscript of 0, usually read as H sub 0. That's referred to as the null hypothesis. And then we have H sub A, H with a subscript of A, and that's referred to as the alternative hypothesis. The null hypothesis, which again is H sub 0, is a hypothesis that is always an exact equivalence. The other way to say that is there's always an equal sign. The alternative hypothesis, that again we represent as H sub A, is always a strict inequality. And our strict inequality symbols are greater than, less than. We're not including the greater than or equal to, less than or equal to. We only want these statements that have strict inequality. And then the last one that we don't see as often, but is still an inequality statement, is not equal to. If two values are not equal to each other, that is a strict inequality. In example 1, we want to write all possible alternative hypotheses for the following null hypothesis. So we have a null hypothesis that states that the population mean represented by mu is equal to 38. The alternative hypothesis can be one of three statements. Either that mu, the population mean, is less than 38, mu is greater than 38, or mu is not equal to 38. We want to do the same thing in example 2. We want to write all possible hypotheses for the following null hypothesis, which states that eta, or the population median, is equal to 105. Regardless of the fact that we've changed our symbol here, we still have the same three strict inequality statements: less than, greater than, and not equal to, which give us our three possibilities for the alternative hypotheses that could be paired with this null hypothesis. Every test will only have two statements, so it would only be one of those three that we would end up using. Similarly, in example 3, now we're dealing with a population proportion. The null states that p is equal to 0.5, so our possible alternatives would be p is less than 0.5. The population proportion p is greater than 0.5, or that the population proportion is not equal to 0.5. So again, we're really just reinforcing here that the null hypothesis always has an equal sign, and the alternative will have one of these three strict inequality statements. Apart from those symbols changing, we use the same parameter and the same number value in each hypothesis.